Oh, hey there, Kev20s, Mr. Riley here, just setting up another tutorial video for stoichiometry. We are going to be doing some solution stoichiometry, so if you guys want to work along with me, you can open up your workbook to number 65. And anytime we're dealing with solution stoichiometry, we are going to be dealing with molar concentration. It's going to always be our conversion factor. And so we're going to be dealing with, X amount of moles per liter, or, X amount of moles per liter. These are going to be your conversion factors when you're doing a solution stoichiometry question. Okay. So let's look at the question that we have in front of us here. It says, determine the concentration of phosphoric acid needed to react with 1.2 liters of a 0.2 mole per liter calcium hydroxide solution if the volume of phosphoric acid used is 400 milliliters. So there's a lot of stuff in there. So let's try to break this down a little bit here. So looking at the problem here, I'm going to jot down a couple of things. Phosphoric acid right away. And go find the chemical formula for that on the acid-base table that's in my data booklet. So I'm going to go and look that up, and it's H3PO4 aqueous. That's phosphoric acid. And I want to know the concentration of that at the end of this. What is the concentration of that needed to react with 1.2 liters of a 0.2 mole per liter calcium hydroxide? So I'm going to have to build calcium hydroxide. So it helps me if I know that calcium is a 2+ cation, hydroxide is a 1- anion, it's a polyatomic ion, and it says the volume of the phosphoric acid used is 400 milliliters. Now, since I'm using molar concentration and part of that unit is liters, I'm going to want to get my volumes into liters as well. So I'm going to convert this into liters. I'm going to take my 400 milliliters, and I'm going to say that, okay, well, I want liters, and for every 1 liter, there's 1,000 milliliters. So I gotta divide this by 1,000, and I'm gonna get 0.400 liters. All right, now my next step here is a balanced chemical equation, like in any stoichiometric problem. So if you guys want to follow along with me here, you want to challenge yourself to try this problem, maybe pause the video now and build yourself a balanced chemical equation. Okay, so now that you have your balanced chemical equation, that is the basic of any stoichiometry. If you can't do that, you're going to be in trouble. So let me show, if you're struggling, let me show how I'm going to write my balanced chemical equation and how I'm going to break that down. So I'm going to start here with my H3PO4. Okay, that's my phosphoric acid. And I am reacting that with calcium hydroxide. And calcium hydroxide, you guys should know, it's a metal hydroxide, and even though it's not highly soluble in water, it's going to act as a base. And so this is a neutralization. It's an acid plus a base. So calcium hydroxide is going to look like that. I need 2 hydroxides for every 1 calcium ion. And then that's actually going to be a solid because at this point it is in solution. Never mind, it is in solution. It's aqueous. I don't want Connor or Angie or Alex yelling at me. Okay, so it's aqueous. And so what we're going to get here is a neutralization equation it's a double replacement equation. So I'm going to get a salt and I'm going to get water. And so let's do our salt first. So I'm going to take my cation calcium and I'm going to mix that with my phosphate. Phosphate is PO4 3-. It's a 3- ion. So I'm going to need 3 calciums and I'm going to need 2 phosphates. And this is actually going to cause precipitate to be formed. This is low solubility in solution. And then my other product is going to be water, H from the acid, and then an OH from the base. And I like to leave it as HOH, at least for now, until I'm done balancing, just because I think it's a little bit easier to balance that with HOH. So let's work on our balancing here. So usually what I'm going to do when I'm doing balancing, I'm going to look for the subscript that is the highest number and try to work backwards from there. So, you know, let me maybe start with the phosphate right here. So I have 2 phosphates on my product side of this equation. So I'm going to put a coefficient 2 here in front of my phosphoric acid and get 2 phosphates there on the reactant side. And now I've got 6 hydrogens over there. So let's throw a 6 over here and see if this works out. 6 hydrogens, now I got 6 hydroxides. So in order to get on my reactant side, get my hydroxides to 6, I'm going to need a 3. That balances out everything. Let's check if the calciums are good. 3 calciums on the left, 3 calciums on the right. Money. All right. So now the next thing I'm going to do is I'm going to write down my given information and my required. My given is my calcium hydroxide. I have a volume of 1.20 liters, and I have a concentration of 0.20 moles per liter. And then I know the volume of my phosphoric acid, it's 0.400 liters. And my concentration, that's what I'm looking for. So that's what I need to find. So looking at this right away, some of you guys might think, oh, I can use C1V1 equals C2V2, the dilution formula. No, you can't. You can only use that if you are dealing with things that are in a 1-to-1 ratio. It might seem like a nice little shortcut, but if you don't have a 1-to-1 molar ratio, it's not going to work. I mean, you could apply the ratio at the end. The math is the same, but I would kind of try to steer away from that. So at this point, why don't you guys try setting that up and solving that stoichiometry? So if you're playing along, pause the video now and work your way through solving for that concentration. Okay, I'm going to show you how I'm going to solve this now. So I'm going to take my required and I'm going to decide, okay, I have to find this concentration. So what I always want to start with is my given quantities. So this is my given. This is what the information I have, and I'm looking for the required. And so where do I start? Do I start with the 1.2 liters or do I start with the 0.2 moles per liter? Never start with a conversion factor. Okay, don't start with the thing that has 2 units, the rate. Always start with the thing that has the single unit. Your rate or your moles per liter, that's always going to be how you're going to be converting something to moles, right? You're always going to be converting a volume to moles, because in stoichiometry we have to get to moles so that we can jump from one substance to another by using the molar ratio. So my starting point is I'm going to take my 1.20 liters of CaOH2. I like to write down what I'm dealing with, and I'm going to convert that to moles, and I'm going to do that using the molar concentration. So I have 0.20 moles per liter. Oops, don't do that, Mr. Riley. Okay, 0.20 moles per liter of CaOH2. Okay, and I can write down CaOH2. Once you guys get good at this, I mean, you can kind of skip through that a little bit, but that's going to get me to my moles of my given. Okay, now once I have my moles of my given, then I have to apply the molar ratio to determine the moles of my required chemical. So my molar ratio here is 2 moles of H3PO4 for every 3 moles of CaOH2. So now mathematically I'm dealing with moles of H3PO4, and I have the moles. I need to find the concentration. So molar concentration is a measure of moles per liter, or moles over liters. So I have moles on top. I just have to put my liters on the bottom, and my volume is 0.400 liters. I'm just going to put a 1 as a placeholder up there. So now when I solve this mathematically, I have moles on top, I got liters on the bottom. I'm going to end up with a concentration here. So let's plug this into the calculator and see how we did. I got my TI-84 Plus Silver Edition here. Shout out to Gurinder. 1.20 multiply by 0.2 moles per liter. Okay, multiply that by the molar ratio, 2/3, and then multiply that by 1/0.4 liters, and get my answer here, 0.4, and I need to have 2 sig digs based on that molar concentration, so I'm going to end up with concentration of 0.40 moles per liter H3PO4. There you have it, kids. Good luck. Let me know if you have any questions.